Hello everybody, Mr. Gazda here. We have 190 coloring P and S waves travel the world. Label the earthquake focus. But before we do that, using the diagram your fine teacher will show you, draw in the S waves. They should be purple. This should have been done in class, but if for some reason you didn't, lost it, or were absent, this is what it should be. These purple lines here. Okay, so it's a series of them. Please note there are black lines drawn on your paper. The P waves are already drawn on your paper, and these are in between them. You're not tracing over them; they're in between the black ones. And what that represents is like this whole area. All of this is all receiving S waves, not just here, but not here, and you know, not like none here and here. This whole area, this infinite amount of them. All this is shaking from S waves. This whole area here is getting S waves. Okay, I do want to make that clear. Okay, the same way that here, this whole area here, all between here, this is all getting P waves as well. This whole, all between here, again, it's not just where the arrows are. This whole area here as well. This area too is all getting P waves. This may be a little bit trickier to tell. I'll walk you through it. This is a difficult concept that I try to use this coloring to help show you. So, label the earthquake focus. So. The focus is the location underground where the earthquake occurs. Now this is so sort of backed out that the focus looks to be right on the surface here. Focus. So that's the first one. The second one, hopefully you should be doing that with the purple. And 3, go over P waves 1 and 4 with brown. So I want to get people to realize that the P wave 1 and 4, how it travels from the focus, it has like a little curvature to it. Right here it gets bent, right here, it's called refraction. So it goes, right, it gets refracted here as it goes into the outer core, and then it gets refracted again as it goes back into the mantle. Okay, so that's 1, and then 4 is I kind of went over it a little bit here. It goes there, and then it gets refracted again in the outer core, and then it goes through there. As it goes to the outer core, to the mantle, it gets refracted again. So that is the brown. Question 4 says go over the P waves 2 and 3 with green. Okay, so 2 and 3, now notice this, it goes through here. Once it hits this boundary, it gets refracted here. Okay, when it goes from the outer core to the inner core, it gets refracted again, kind of right there. Again here, and again here. I didn't do a great job drawing it, I will admit that. I did it a bunch of times, I just couldn't get it really right. But, so that's 2. 3, here, refracted here. Refracted here again, refracted again, refracted again. Okay, and that's the idea, is showing that every time it goes to a layer with very different properties, in this case they are different densities, it causes refraction. Okay, so it gets refracted at this layer, at this boundary, at this boundary, at this boundary. And that's the point of this. This is, again, not a coloring assignment. The point is to understand how we see these waves traveling through the inner Earth. 5. Excuse me. Find the areas of Earth's surface that do not receive any P waves. There are 2 separate areas. Lightly color these areas yellow. Now we're talking about Earth's surface. This is all inside Earth. Earth's surface is all here, so it has to be here. The 2 best areas that don't get any P waves are the largest ones. May not be super obvious to you, and sometimes it isn't, but it's really right here. Now this area here, okay? And then this area here, between here, they don't receive any P waves. Okay, now I'm going to show you this. Hopefully this will come through well in the video. I'm going to give this a shot. So here I have a globe, and how else is it going to come out? So here I have a globe. Let's say the earthquake happened right here. This is the epicenter of the earthquake. Maybe I'll do it like this. See if I can do this. Here, right? This will be the P wave. So all of the black, this is all the black right there is locations that receive the P wave. Okay? So that's, again, where the earthquake happened, the focus. Now if I look on the other side of it, okay? So this is the other side of the Earth, right there. Okay? If I relate back to my sheet, so this is a little hard for me, I'm not used to doing this. If I resort back to my diagram, that area on the bottom is like right here. Okay? The waves get through. Now the yellow spots that don't get any waves because of all the refraction there and there is shown by this area here. If I can zoom out. See that? Okay. It's hard to show it, but that's what that is. That's called the P-wave shadow zone. P-wave shadow zone. Okay? So, that's key. Let me try to get this back up on there. Holy cow. A little all over the place. Forgive me. Alright. So, we have that. Let me put that over here so it doesn't get in our way. Okay. Where are we now? So we're on the 6. Find the areas of Earth's surface that does not receive any S waves. Lightly color this entire area blue. Again, on Earth's surface. The S waves here are all the purple. So there's a big area here, and I'll use like a light blue. The purple, see purple here and here. These purple waves stop right here. So the area that doesn't see S waves is kind of all of this. All this area here. Okay, I'm doing it. This huge chunk does not receive any S waves. And the reason that is because we know S waves do not travel through anything that is liquid. They can't travel through anything liquid. So these waves here, while the P waves can go through liquid, they get transmitted through the outer core. They apparently do not go through. They just stop right there. And we don't see them on the other side of the Earth. That is how we know, or why we believe the outer core is liquid. This is why, because we don't see S waves on this side. And we know S waves can't travel through anything that's liquidish. Here I have another, here's my, this shows an earthquake. Okay, let me do this. This shows an earthquake right here. Again, that's the epicenter of the same earthquake. Now the green lines will show all of the locations on Earth that will receive S waves, if you can do this. Okay? Right? Now if you look on the opposite side of the Earth, this whole big area here, the whole big area on the opposite side of the Earth does not receive any S waves. Okay, that's the S wave shadow zone, and it's really about half the Earth right there. So what I'm relating to, that is all the blue stuff you colored blue. We colored blue. Hold on. No.